Buenas tardes. Muy buenas tardes con todos. Con nuestra presentación. El día de hoy vamos a tener a la doctora. Se encuentra Sonia. Doctora Sonia.
Hi, hello. I'm here.
Hi, doctora. Ok. Bueno, días con todos. La doctora investigadora federal de Brasil implementó el método de datación de la luminiscencia básicamente en censos fluviales recolectados en el Amazonas. Su interés en investigación, datación de terrazas, sedimento, datación método de único, síntesis y caracterización morfológica, y el día de Amazon Research and Defense Pablo Brasil implement optically accurate luminescence dating sediment collection. His research art marine terrain dating by congregate logical characterization in the section. In today, the present has with intellect or indicate that. Doctora, I speak. Hi.
It is good thing. What did
Uh,
you say?
yeah, right. Okay. Doctora, puede comenzar la presentación. Your chunk here.
Can I start now?
Yes, please.
Okay.
Ah,
So I will start. It is okay. Everybody can see my presentation.
Yes, we can see.
Okay. So thank you very much for inviting me. And yes, I am Sonia from Federal University of São Paulo. My talk is very different from the theoretical physical experiment. So today I will talk about optical stimulated luminescence applies to dating of Amazonian River sediment. And the summary of my talk, I will start with some theoretical concept about OSL, quartz OSL, the dating method procedure. We use this protocol single electron regeneration, that name SAR, and use statistical age model. Then I will talk about some quaternary geology application. It is a interdisciplinary research with the geologist team and some conclusion, and I will show something about my laboratory infrastructure and my colleagues. So, OSL dating was started with Hunter et al. Work 1985, and they date the quartz crystal using green argon laser. So, what is OSL? Now, optical stimulated luminescence is an unstuck process. So, we excite, for example, quartz Using blue light, the quartz absorbs the energy from this light and then emit um, light in ultraviolet region. So it's low energy absorbing and high energy emitting by unstuck process. This is OSL. So, and in nature, what it is happen? The OSL is emitted uh, by exposition of sunlight. No? So the sunlight has blue light. Then when the quartz is exposed to sunlight, the OSL emission can go on. Um, Here I put thermoluminescence. Thermoluminescence is another luminescence uh, kind of the crystal when they are heated. If you heat the crystal can emit GL. Um, the thermoluminescence also can be used for date the samples, GL and OSL. So the zero age of the sample uh, can occur when the sample are exposed to sunlight or when the sample begin to form. So when the crystal is the signal is zero, then the age also is zero. Um, so we can date stalagmite, sediment deposition, or archaeological potteries, ashes, stone. And there are several samples that you can use for dating. So the OSL process involves the band theory model. So in this case, you can see the crystal, the crystalline net in three regions. Valence band, when you have the electrons here orbiting the nucleus. This is the forbidden band when you cannot have electrons, and conduction band, then the electron is free. So when the ionizing radiation, which come from cosmic rate or uranium, thorium, or potassium, that are the radioactive element in the environment, the natural radioactive element, and they can emit the ionizing radiation like gamma rays, beta particle, alpha particle. So this radiation can deposit the energy in the crystal. So when the crystal receives this energy, the crystal can transfer the energy to the electrons, and the electron in the valence band can go to conduction band. And in the same time, you can see some holes. Holes is mean positive ions also moving in the valence band. So then the electron can be trapped in the forbidden band. This trapped is the impurity in the crystal or defect in the crystalline net. So the electron can trapped in this traps, and the hole also in the same way. So this happens when the crystal is here receiving the ionizing radiation. So if you take some sample from the beach or where else, then you go to the lab and you can stimulate the crystal with, for example, if it's quartz crystal, you stimulate with blue light, then the electrons absorb the energy from the blue light, goes to the conduction band, and can recombine with the hole that is the positive ion. eh. Then, with the recombination, they emit light in ultraviolet region. This light we name OSL, the optical stimulated luminescence. So the intensity of this signal is proportional to the concentration of the electrons trapped in forbidden band. eh, and consequently, the concentration of these electrons in forbidden band is proportional to the time that this crystal was exposed to the ionizing radiation. This time we call age, the sample age. The sample age in this case is from the last time that the crystal receives sunlight. The crystal is born in the in the in the layers of the sand, for example, then stop to receive sunlight, it starts to receive ionizing radiation. eh. From this time to the present is the age of this sample. eh. So the OSL signal is proportional to the sample weight. This is the base of the OSL dating. So actually, the band model applied to quartz crystal is not so simple that like I showed for you. Now, for example, we have some complex band model for explain the OSL signal. No? So you have a lot of several center that electron can be trapped. So some centers is origin from the OSL and they can recombinate here in the hole traps. This is some specific hole traps that can be used to OSL dating. The typical OSL decay curve that we obtain from quartz collected in Amazon is showing here. You have, for example, natural OSL. So we just take the sample, clean, chemical clean, and made the measurement. Then we obtain this blue curve here. Uh, so you expose the quartz with blue light. No, they emit a peak here in the OSL intensity very high in the beginning. Then they start to decay until some background intensity. The electron will be retracting that, and the recombination occur. Then the concentration of the trapped electron and also decay. Then you can see this like exponential um, behavior. If you take this alectate that you already measured yourself, then you apply some dose uh, from ionizing radiation. We use beta particle, artificial beta particle source. Then for example, you can choose the dose that you can apply. So in this case, we apply 7 gray. Gray is joule by kilogram. On 7 gray, you obtain this red curve. If you increase the dose, 13 gray, you have the green curve. Uh, so you can see, for example, 20 gray, the blue curve. So you can see the maximum intensity now or the whole curve increase with the dose. So, for example, you can take the maximum intensity versus dose né, and plot the OSL growth curve. Né? So you can see some increase in intensity when you put some dose. So you can take the natural intensity here, for example, and in this point, intercept point, you have the dose that your crystal receive from the nature. Uh, so this is how you can obtain the dose accumulate in the crystal. Here you can also what is the convolute this OSL curve. Here we use general organic order, and then we can see that actually the experimental curve is composed with three components. And the fast component, a medium component, and long component. So you put the measurement did we at room temperature, and here the component um, measured at 160 degrees C temperature. Then the fast component decay more quickly. If you measure with your room temperature. Generally, we measure with some temperature for eliminate very shallow trap electrons present in the normal sample. This is another kind of OSL measurement. In this case, we increase the intensity of excitation from the 0 to 19%. Then you can see the OSL, the linear modulated OSL signal. So in this case, it's not exponential shape. They supplied a peak here. Then you can deconvolute the experimental curve and, for example, found the three components again. And this is ours for quartz from Amazon that we studied. So we can characterize the signal theoretically using the general order kinetic because the electrons can have many ways and when they are released from the trap he can recombine directly or he can retrap it again. So this probability you can see with this parameter B, the retrapid and recombination probability. So the age equation is showing I show here. G is equivalent dose of the energy accumulated in the crystal. That I shown in the slide. The total dose accumulated in the quartz coming from the ionizing radiation. So uh, you can determine this value using OSL measurement. Then, for complete the age, you can have the annual dose radiation. The rate that the ionizing radiation deposits the energy by year in the crystal. So if you have this rate, that depends of the radioisotope concentration in the environment and the annual cosmic ray rate. Uh, then you have the rate in gray joules by kilogram by year. So here you have gray and below you have gray by year. So you can cut gray and gray, then you have age, you have year, that it is the age of your sample. So I said GA equivalent dose is determined from the OSL measurement. The rate below is determined. We determine it using gamma spectroscopy. Gamma spectroscopy is used for determining the radioisotope concentration. You can also use neutron activation analysis. It's very precise method also, or SPMS. Well, well, you have also do some water content correction when your sample are immersed in the water, like a river sediment. The water can absorb the energy, and the energy that is going to the quartz, the water absorbed. Then you have to correct this this portion that water absorbed, and then you put the correction here. So the calibration of the sample showed to be for it at its aliquoter, because from the quartz, from the grain to the grain, they can respond different because the defect and impurity that trap the electron can be different the grain to the grain. So this calibration we have to do um, uh, separating some portion that we call aliquot. This aliquot is about 3 milligrams of the grain. So you use for determining the accumulated dose, the energy in the crystal. We use the single electron regeneration. Uh, the name is SAR protocol. Uh, in this case, we put the aliquot in the machine. Then you can write the program. In this case, the basic program starts with the preheating about 220 degrees C to eliminate the shallow traps contamination. Then you measure the natural dose here, the OSL from the natural sample. Then you irradiate with the dose test. Then you can use some constant dose test about one grade, 2 grade. Generally is very low. Uh, then you preheat and measure the OSL signal from the dose test. So you start the regenerative radiation. Então, will be those that you regenerate the signal. Between these regenerative dose tests, you irradiate again with those tests that you use here, the same dose. So between this measurement, you irradiate and measure the dose test. So if the aliquot doesn't change the response in this procedure, the OSL test that you put here should be the same intensity. Okay, so this is why we use the SAR protocol. In this case, you always use those tests to see if the response is changed or not. So also the SAR protocol, you have to perform two tests, the regeneration test. In this case, sometimes you have sample that emit OSL without any previous radiation, previous dose. So this is not good for your dating. And so if the sample show this behavior more than 5% of natural OSL, you have to eliminate this aliquot. Also, this is recycling test. In this case, it is the same that I said for you, that if the response change in the process, this change more than 10%, then you have to eliminate this aliquot also. So you generally, for dating one sample, you have to test about 20 or 15 aliquot because 20% of the aliquot do not pass this test. So you have to eliminate. So we work only with normal behavior adequate for perform the dating. Here we use I show you the fluvial sediment case. Um, that sometimes the zeroing does not occur heterogeneous. So some aliquot can have a low value and another very high value of those. So you have some distribution of equivalent dose in the same sample. So you have to perform a very deep statistic study in this result for give real age of the sample. Nowadays, we use this radial plot model. Using radial graph and these three models, we can evaluate the equivalent dose or the age of the sample. For example, here we have some fluvial sample from Amazon. We determine this results is of accumulate dose. If we use the central age model, we obtain here the equivalent dose value. This is the X, and using central age model, the equivalent dose will be about 6 gray, for example. If we use the minimum wage will take the aliquot that supplied the lower dose. So we have some value below 5 gray. Or you can use the finite mixture model. In this case, we have three probability. Or your sample has 3 age. Maybe the mixture of 3 age. This can happen, for example, in archaeological site that was used in different time, occupied in different times, for example. If the dispersion over dispersion of the result is lower than 20%, for example, we use the central age. If it's higher than 20%, we use the minimal wage. The finite mixture model you can use always. There is no over-dispersion value related here. So, I finished the theory of the OSL dating. Here I will show some interdisciplinary goals. It is studied with the geologist people that work in the Amazon. Here you will have the map of Brazil. Here. Here is the Amazon River, okay, and the tributaries. We work with the Negro River here. also Tocantins. And why we use OSL data in this region? Because as you can see, there are a lot of rivers tributaries that can deposit sediment. So you can find sediment in all this place. So it is very nice site to apply OSL data. And because the very rain climate, né, they found few fossils of sample that can be used for carbon 14 dating. So they took the sample, the sediment sample, and we can perform the OSL data, and it's a very helpful tools for the geoscientist people. So, the preliminary work of the group is what was made here was the paleodunes, né? The paleodune was covered with vegetation and very old dunes. So we date here. In that time, we used thermoluminescence. Was not OSL, and we found the age from 33,000 to 8,000 years ago. And this age, this paper argues again the current old model that no drastic ecological change did not affect the Amazon during the last global glaciation. And then we prove the opposite case, because in this time the Amazon, the north part of Amazon indicates a very dry climate region. Then form the camp of dunes, a very camp with high extension, and so it's not humid climate like present. Another work is in the about rate sedimentation, rate sediment that in the Solomon rivers here. This is the tributary of Amazon River, yes, the Nego River, Solomon River. So here, generally, we have to determine the uranium, thorium, potassium for annual dose rate, water content. Here is the accumulated dose in the sample and the age. So we have two protocols, multiple aliquot and SAR single aliquot protocols. Nowadays we use only SAR protocols. Now this age varies from 1.3 to 674 kilo years. Then they also to late Pleistocene. Yeah, this picture showed how you can take the sample for us using aluminum tube, because the sample cannot be exposed to sunlight. You use the inner in the tube for the OSL dating. This is the photograph of active channel. So we also date the Paleo Channels River. This channel, there is no river moving here now. It's abundant channel. Then the geologists date this channel, and they can see how the river change the direction. So it's very nice application for the dating. This is another. In this case, a very long times ago, Amazon River cannot go to the western part, to Atlantic, because this formation named Purus Arc, and then do we the what's this? When the times go on, the erosion or subsidence of geological features promote the connection between the western and the eastern part here. Then the Amazon River could drain to the western part, to Atlantic Ocean. And we date several samples in this region, and the geologists conclude that this erosion happened in mid-late Pleistocene. So the mid-late Pleistocene is about 226 to 781 kilo years. Then in this time, the Puru Arcus was erosionate, and the Atlantic, and the Amazon River can go to Atlantic Sea. So it's also amazing work. This is also continues the rate deposition of the river here in the Solomon River also. So here they concluded that the deposition and the peak of the deposition is occurred in the 50 kilo years ago. This is another amazing application. Is about megafan dating. Megafan is a large corner built with complex deposition pattern of stream flow originate from a single point. So the rivers, the water open here like a fan and deposited the sediment with this particular shape. Here we also date sediment in this extension, and the mix also they have some hydrocarbon age because we can correlate. It's OSL age ranges from 70.5 to 2 kilo years. This is in agreement with this carbon age interval. And here, we have 1460.9 kilo years. The carbonate cannot date very old sample. They cannot take this other interval of years. So the conclusion that the group has been working on interdisciplinary project with geologists in the Amazon since 2002. Dating sediment originate from the Great Amazon, Negro, and Solomon rivers and the tributaries. The use of crystalluminescent age has been one of the most promising tool for determining the absolute dating of Quaternary deposits in the Amazonian region. With this age obtained by OSL, they can reconstruct the history of the region, such as rich sedimentation, change in the river course, formation of megafans, tectonic activity, and etc. They are also able to correlate this event with the great glaciation that have occurred in the past. And finally, a new theory model regarding the change in the landscape can be written for the Amazon based on this study. Well, here is the instructor of my laboratory, state in dosimetry laboratory. We made research with dating and also luminescence dosimetry. Now we work with nanocrystal, synchronizing and characterization of nanocrystal. We have a RISO equipment. Without this equipment, it's not possible to use the SAR protocol because the hydrogypsy is coupled to the equipment. Um, this is my collaborator. Now we are in 1, 2, 3, 4, 5 professors. Juan Mitani, Nilo Mamana, and Daniel Waka, they are from Peru. Marsui is descendant of China, and he's Professor Nagabushana from India. They are my student. So it's the laboratory. We have people from several places. Also Brazilian, of course. I am Brazilian. My grandfather was Japanese, but I am Brazilian. So, thank you very much for your attention. I don't know if I'm very thanks.
Okay. Thank you very much for your presentation, Doctora. And um, any question for Doctor?
I have a question, please. Well, two questions. Sorry.
Right.
Okay. Thank you so much, Dr. Sonia. Well, my first question is concerning if this kind of project can be used to analyze Millennium El Nino phenomenon, probably.
Yes, yes. We can, they can correlate with what is the climate problem, the fluctuation of the climate, variation of the climate. It's not, we can start to date sample with about 400 years. Yeah. So if we want to do some present problem, is not viable. But older than 400, 500 years, we can study. They use if we get marine sediment, they correlate with sea level change.
Okay, super.
Mhm.
My second question is concerning the numerical model to projection to the future. Is possible to assimilate this data in this kind of models to projection in the future, like SEMIP 5 or SEMIP 6?
Oh,
So,
I don't understand. Uh, you can speak in Castellano. I think I can understand.
Oh, sorry. No problem. ¿Es posible asimilar este tipo de información en modelos de proyección a largo plazo, como los famosos semi? ¿O no estoy muy seguro de eso?
Yes, they use the dating result, as I said, for climate problem. But there's more to establish what happened in the past, model in the past. In- uh, so um, so use this model. Now, what happened in the past, maybe they can formulate what will happen in the future. I don't know if it is the question.
No, okay. No problem. Thank you so much.
Uh-huh.
Other question?
Yes, I have a question, but I speak in Spanish, if no problem, doctor.
No problem. I cannot speak in Spanish, but I could understand.
Okay, thank you so much. Este método puede ser utilizado para poder analizar variaciones de temperatura. Me explico. Digamos que un problema actual es sobre el cambio climático y algunos gobiernos, digamos, tienen esa resistencia sobre que no varía mucho la temperatura, pero estudios indican de que en épocas antiguas, pues la variación de la emisión del CO2 natural sí generaba cierta variación de temperatura, pero no tan drástica como actualmente. ¿Puede este método utilizarse para poder dar esa información y poder generar un protocolo de cuidado medioambiental?
Yes, you can use, for example, the dating of dunes, dune sample, duna. Uh, uh, Dune is indicative of dry climate. né? So I give the date, then the geologist knows when the dry climate occurred. né? So dry that form the camp of the dunes. né? So you can also, if you have, for example, some pollen, paleontology, paleontology study with dating, we can determine the climate because you have what kind of vegetation is growing that time, and so you can correlate vegetation grow with humid climate, dry climate, and you can determine the kind of the climate in that time.
Okay, thank you so much.
Other question?
Buenos días, yo tengo una pregunta.
Uh-huh.
¿Es posible esta técnica aplicarlo de repente para saber la época en la que fueron construidos de repente algunos restos de textiles o de repente restos humanos?
Jim, yes. You can date the soil of the archaeological site. You can date, for example, the house, the brick. Yes, you can discover the age of the site. Yes, you can use.
Gracias.
Okay.
Okay. Other question? Nothing. Okay. Very much. Muito obrigada, doutora. Muito obrigada pela apresentação. Continuando com nossa... Acho que continuamos, ¿no? Continuando con tenemos 2 salas a partir de ahora, dos presentaciones. ¿Cierto, Medina?
Yes, okay. I will the presentation. Thank you very much to all. And now for this interest in theoretical physics today, we have an oral presentation session in that will take place in the round one. I put the link in the chat. There is this presentation by Ariman Kumar Chatterjee. He was presented this time. Sorry. The lectures will resume at the 2 p.m. in Peruvian time with the presentation of the Dr. Antonio Pereira and Dr. Enrico Bertuso. If you want, going to the enter and the link I was pushing in the chat. Thank you so much, everyone. Again, we leave this room and see you again at the 2 p.m. 40 hours. All what you see. Thank you so much, and this.